I read a problem description, then I instantly get it. This is max sum of pair with equal sum of digits. All right, so I have yet to solve this problem. Have yet to even read the description, but I decided that instead of doing the problem, solving it, then making a video, maybe I should just solve the problem in real time. And if you're seeing this video, must have meant that I did successfully solve this problem. Otherwise, I'd likely not post it. So, with that said, let's go ahead and get right into the problem. Okay, so you're given a zero-indexed array nums consisting of positive integers. Okay, you can choose two indices I and j such that I doesn't equal j, and the sum of digits of the number nums I is equal to the sum of that of nums j. Okay, so digit sums, I'm guessing it's meaning like if I take 1 and 8 together, right, 18 equals the digits 1 plus 8, which equals 9. And 43 equals the digits 4 plus 3, equals 7. 36 equals 3 plus 6, which equals 9. And 13 equals 1 plus 3, which equals 4. And 7 equals 7, which equals 7. 777. Praise the Lord. So I guess we're allowed to choose two indices if they have the same digit sum, right? So 43 and 7 together have the same digit sum, and 18 and 36 together have the same digit sum, right? Because these are both 9 versus 43 and 7 are both 7. Okay. Return the maximum value of nums I plus num j. Note that you can obtain over all possible indices I and j that satisfy the conditions. Okay, so all right, 10 to the 5, 10 to the 9. So the easiest solution, right, the brute force solution would be to look at all ij pairs, right? So look at all n squared ij pairs, check if their digit sums are the same, and then if they are, add them up, and then do the maximum of that, right? So you look at all ij pairs. For each ij pair, you determine if they meet this condition of having the same digit sum, and then taking the max of all of them that meet that filtering condition of having the same digit sum. But that's going to be n squared time, and for nums league 10 to the 5, that's 10 to the 5 times 10 to the 5, 10 to the 10. That's going to be far too slow, right? We're going to get a time limit exceeded error. So instead what we can do is, well, we can kind of filter out. We don't have to look at all pairs. Okay, so since we don't have to look at all pairs, we can easily filter out the pairs that aren't going to work without looking at all pairs together, right? If we just look at each number and say, okay, well, 1 and 8 equals 18 equals 9, so that goes in the 9 column, right? And 4 and 3 equals 7, so that goes in the 7 column, right? 36 is 9, so that also goes in the 9 column, right? And 13 equals 4, so that goes in the 4 column. And 7 equals 7, so that goes in the 7 column. What I'm basically saying is, well, I don't need to look at all pairs. I just need to know what the digit sum is for each number. That way I can determine all the numbers that meet that condition. So now I know I can only combine 18 and 36. I can only combine 43 and 7, and I can only combine 13. I guess oh, interesting. If there's nothing that meets a condition, return -1. I probably said that and I just didn't notice. Look, it doesn't even say that, right? But I guess you're supposed to return -1 if it doesn't meet the condition. So it's not the best written problem, but that's neither here nor there. So the idea is instead of looking at all pairs, I can just figure out what number, what digit sum each number corresponds to, and then from there I can already know what the pairs are that I can check, right? So I've limited it down to the pairs that I can check now, right? Instead of checking every pair, I don't have to compare 18 to 43 because I already know that 18 and 43 don't meet the filtering condition. So this is a way to, in n time, find the pairs that work, right? And then I guess the next thing we need to do is, well, The next thing we can do is what? Well, see, the thing is that in this problem, it's neat. But what if you had additional values, right? Like if you had X, Y, Z, A, B, C, meaning you had additional values that had the digit sum of 9. Well, then you'd have to check all these pairs, right? The idea is you'd have to look at all of these pairs, right? You'd have to compare 18 to 36, then 18 to X, and 18 to Y, and 18 to Z, and 36 to X, and 36 to Y, and 36 to Z, right? So now you're having n squared pairs there. So if all the numbers were in the same pair, you'd still have to do all n squared pairs to find the max, right? If you were just looking at them arbitrarily. But since we're only looking for the maximum value of nums I plus nums j, we only need to look at the two largest num pairs that equal 9, or the two largest num pairs that equal 7, right? Because that'll add to our largest solution. So we don't need to look at all pairs. We just need to look at the two largest values here. So we only need to keep track of that information, okay? So I guess the first part of this problem is we need to figure out how we're going to take a number and find its digit sum. And the way that we'll do that is we'll do digit sum, and we'll set it to a default dict. Trying to think about how we're going to do this. I'm trying to think about how to do this in a cute way. We'll just do it as a list initially, and then maybe we'll expand it to something a little bit more interesting. So the way that you can take a number, and this is probably something you should know if you're doing a medium problem, but the way that you can take a number and convert it into its digit sum is like so. So we'll look at each num and nums to find each number's digit sum. And then the way that you can do it is we'll have a total variable equal to 0. Now, if I take 18, here's how I can find its digit sum. If I mod it by 10, I'm going to get 8. So that's the value of the first digit. Then I'll take it and divide it by 10 to get 1. And then I'll take 1 divided by 10 and I'll get 1. And then 1 divided by 10 equals 0. So I'll do that with a bigger number first. So like 1, 2, 3, for example. If I take 1, 2, 3 and mod it by 10, I get 3. Not 4, I get 3. And then to remove the 3, I'll divide it by 10. And I'll get 1, 2. And then I'll take 1, 2 and mod that by 10 and I'll get 2. And then I'll take 1, 2 and divide it by 10 and get 1. And I'll take 1 and mod it by 10 and get 1. And take 1 divided by 10 and get 0. So if I just take all these mod values, 3, 2, and 1, and add them together, I'll get the answer, right? So I'll say, while the num exists, t plus equal num mod 10, and then I'll take 10 and I'll divide it by 10. I'll take the num and divide it by 10. All right. And then at the end, I'll just say, okay, ds of this value, we're going to append num. So at the end, what you should see then is kind of something where, you know, the digit sums have their the associated values that lead to that digit sum. Right. Right, so 9. Oh, the problem is that I'm taking num and I'm turning it into 0. So by the end, you don't even know what num is. So, yeah, yikes. So tnum, it's not very good, not very cute, but just so we get this problem done, because I got to get back to work, so I don't want to make this too cute. So 9 has 18 and 36, right? Like we said, right? Because 18 and 36 both have the digit sum 9. 7 has 43 and 7 because they both have the digit sum 7, and 4 just has 13. So we're trying to find the 2 max, right? So now what we do is we return the n largest for each system. So the n largest, if you take a heap Q and you do the n largest, I'm trying to remember how this works. It's so annoying how this... So we'll return the... I just picked my nose on screen. I forgot that I was doing a video for a second there because I'm really tired. Okay, so I'm returning the max of heap Q and largest. So what I'm trying to do is I'm trying to get the two largest from each of these systems, right? I'm going to do it the long way because I don't want to complicate this for the viewers and for myself. So I'm going to say the maximum solution, we'll call it res for the result, is -1 because that's what you return if there's nothing, right? And then we'll look at each value in ds, and we'll say if the length of ds of v at that value is greater than or equal to 2, because you need at least 2 values to find this pair, right? Then we just say res equals the max of whatever we think the max is, and heap q dot n largest, we want the 2 largest from ds of v. And then at the end, we just return res. So I was thinking about a one line way of doing this when it's a little bit oh, so we need to sum the 2 largest values together. All right, cool. So what's the runtime? It's 100% better than it. No. So what's the runtime of this? Well, you know, we create this default dict. We look at each number, and then for each number, we divide it by 10 to get a digit sum. So we have to look at all log m. It depends on depends on how you look at it, right? Because okay, so let's just do some establishment for this time and space. Okay, so for time we have to look at, let's say that let's say that n equals the length of nums, and then let's say that m equals the length of each num, right? Or m equals the max num. How about that? M equals the max num, so it's the largest number, right? Well, for each number, we have to look at all n nums, and then we have to look at all m log m digits, right? Because if your number is like this, say your number is 999, right? How many operations are you gonna have to do it? We're gonna have to look at the first. 789. If it's 789, you have to look at the 9, then you have to look at the 8, and you have to look at the 7, right? That's what you do in this loop. So if there's 789, you look at 3 digits. So if you thought about that, it's log m, right? So I have to look at all n digits, and then for each n digits, I have to do log m operations to get each of the digits from that digit, right? And then here, I just look at all the values that I could possibly have. In the worst case, they all have unique values, right? So I look at all n values, and then I just determine the maximum of what res was and the 2 largest values. The reason why we do n largest 2 is because then we just look for the 2 largest things. We don't have to sort the whole system. We just need to find the 2 largest things when we go through the whole system. So this takes yeah, but it'll be for each one. So I don't have to sort the whole thing. I just have to look at each that's 2 largest values in the whole system, right? So this will be proportional to n as well. So that means that it's n log m to do this and n to do this. So that would be n log m in total. What about for space? Well, for space, we just use this, I guess, digit. I don't know what I call that. Digit set or something. Digit set to represent the digit sum. Sorry, the digit sum for each number. In the worst case, each digit has a unique digit sum. So we have to populate, for n numbers, we have to populate n digit sums. And then for each n digit sums, we have to populate its corresponding value once. So that's just O of n as well. And I forgot to put O here because I'm a fool. All right, guys. Hopefully this was a little helpful. I just did this live, so I was trying to reason through how this is supposed to work. This could definitely be a lot shorter, but for the interest of time and my sanity and yours, we'll just leave it as it is. All right. Peace out.